Today, for the very first time in my life, I'll be exposing my secret method of solving questions on dimensions to the public. And as a bonus to those taking WAEC and A-level examinations like JUPEB, 100 level, university physics, and what have you, I will be showing you how to solve questions on the applications of dimensions, including the dreaded principle of homogeneity. So, if you are new here, this is Dr. Jeremiah, a medicine and surgery student of the prestigious University of Ibadan, popularly known as the first and best university in sub-Saharan Africa. I post educational videos like this and video tutorials on important concepts from the whole level syllabus that 99% of students neglect, that cause them that dream score or grades in their various science exams. Alright, so let's get started with this video. Alright, today we're looking at dimension analysis. Alright, so let's first start with quantities and units. What's a quantity? A quantity is that property that is about to be measured. So let's take, for instance, length, mass, time, and all of them. So these things are quantities. What you want to measure, the property that has been measured, so that's the quantity. This is not a video on quantities and units, but it's supposed to be on dimension. But let's just start from there. So we're going to build on this later. So what is a unit? A unit is the yardstick with which a quantity is being measured. Take for instance now, the unit of length is mass. So we're going to measure length in meter rather, not mass. So you're going to measure length in meter, mass in kilogram, and all that. So that's the units. Now let's quickly talk about fundamental quantities and derived quantities, fundamental units and derived units, because these quantities and units are divided into fundamental quantities, derived units, and fundamental units, derived units. So basically, fundamental units and derived units, and the fundamental units and fundamental quantities go together. So when you have unit of a fundamental quantity is known as a fundamental unit, while the unit of a derived quantity is known as a derived unit. You get? So although we also have what we call supplementary units, but it's not basically important for most exams. But just take note that there are 7 fundamental quantities in physics, 7 fundamental quantities and 7 fundamental units. So for instance, the 7 fundamental quantities are length, mass, time, temperature, amount of substance, luminous intensity, electric current. You get? So these are the 7 fundamental quantities, and their units. We have meter for length, kilogram for mass, candela for luminous intensity, Kelvin for temperature, moles for amount of substance, amperes for electric current. I think I've said all of them. So these are the units of the fundamental quantities. So please take note of them. Then any other units and quantities outside these 7, they are known as derived units, except the 2 supplementary units we have in physics. So the rest, aside those 2, the 2 are called the steradian and the radian. So apart from those 2, every other are called the derived unit and derived quantity. So please take note of them. Now let's quickly run. Now what's dimension? What's dimension? The dimension of a quantity tells us how that quantity is made from the fundamental quantities. How this quantity is made from the 7 fundamental quantities like we just said. So that's the dimension of a quantity. And let's quickly do a rundown on these 7 fundamental quantities. And I will be smashing it with the representation in dimension form, because they have different representation in unit form and in dimension form. Let's take for instance mass. Its unit is kilogram. So you can write it as kg. But its dimension is not kilogram. Its dimension is represented as m. So I think we're going to be comparing both of them. So its unit is kilogram, while its dimension is represented as m. Now for length, its unit is meters, small m, while its dimension is represented as L. So please take note. Then for time, the unit is seconds, which is s, while the dimension is represented as t. Then for what's the next one? For temperature, Hope you are following me. For temperature, the unit is what? The unit is Kelvin, said it earlier, while the dimension is represented as theta. So please take note. It's not represented as T. Some people say it's T. It's not represented as T. It's represented as theta. Each time that is represented as T. Those of my secondary teacher will tell you that just take the beginning of the word because mass is M, length is L. It's not true. So that's why I'm saying this. I'm supposed to just skip this part. Then after time we have temperature, electric current. Electric current, its unit is amperes, represented as A, while its dimension is represented as I. So please take note. It is not represented as E, as a secondary school teacher will say. That is not correct. Then mass, length, time, temperature, electric current. We have amount of substance. Amount of substance. Amount of substance is represented with mole. While its dimension is N. So please take note. The dimension of amount of substance is N, not mole or M. So please take note. Then after amount of substance, we have the luminous intensity. Hope you are following me actually. The luminous intensity. Luminous intensity, the unit is candela, abbreviated as CD, but its dimension is represented with J. Maybe you have not seen this before, so please take note. Its dimension is represented with J and not L or CD. So in case you see it in your exams, probably 100 level, whatever exam you see, JUPEB, please take note of this fact I just stated. Now we have looked at these 7 fundamental quantities and their dimensional representation. These are units, these are dimensional representation. Okay, now that we have known the dimensional representation of the fundamental quantities, which we are going to use to express in dimensions of all the quantities in physics. Now we have known them. Now let's look at some questions. I'll be teaching you 3 methods today, if time permits. 3 methods. 1 is the expansion method, 2 is my shortcut method, and the third one is also my shortcut method from using the options. So I'll be showing you these 3 methods today. Let's start from the expansion method. Why I'm teaching you the expansion method first is you need to first understand the concept before you go to my shortcut method. This is a shortcut I used to get in my answer anytime, any day. You get. Now let's quickly move. Now let's look at the dimension of torque and power. Torque and power. I think we are going to start from the expansion method. So please take note. The expansion method, torque. This is the basic one you know. Why I'm doing this for newbies, so as in case you have not done dimension before, you can understand. So what is torque? Torque. The formula for torque is force times perpendicular distance. But let's just write distance. Perpendicular distance. Force times perpendicular distance. Like I told you, if you have not watched the video where I was teaching you how to become a god in physics, how to solve any physics problem, please go back to that video. I was saying in that video that you must not necessarily learn all the units or dimensions in physics. For instance, I don't need to learn what's the unit or dimension of torque. From the formula we can derive it. Now this is what the expansion method is telling us. So torque equals to force times distance. So make sure you watch that video. I'll place the link in the description so you can watch that video. So let's quickly run. Torque equals to force times distance. Now we go, what's the formula for force? This is the expansion method that you have been taught. Force equals to mass times acceleration. What's the dimension of mass? We have said that the dimension of mass is represented as m. So what is acceleration? Acceleration is change in velocity over time. Change in velocity over time. And now, what is change in velocity? What's the dimension of, or what's the formula of change in velocity? Change in velocity gives us change in displacement over time divided by time. You get it? Now, we already know the dimension of mass as m. Now, the dimension of displacement. What's the dimension of displacement? Displacement is measured in length, in meters. So, in terms of length. So, the unit of displacement is meters. Now, if the unit of displacement is meters, what is meters here? Meters is length, and dimension of length is represented as L. So, it means that the dimension of displacement is L. Now, what is the dimension of time here? Dimension of time here is presented as capital letter T. We're going to have T. Then, what is the dimension of T of time? We have T also. Now, you have M times L over T divided by T. Now, from basic principle of math, you can basically just do M times L over T times 1 over T. Yes, so remove the division sign. So from there, you're going to get L over T squared. So hope you are following me. M over T squared when you times the 2T on that. Then from there, you're going to bring T up using the laws of indices. Like I told you guys in that video, after becoming good in physics, that you need some basic knowledge of mathematics, and stuff like indices is very important. So now, for instance, we are bringing time up. It's going to now become T minus 2 because we are bringing time up. Alright, so you see, from the basic principle of math, we're going to get the dimension of force. But from our formula, remember that the force times distance. So now the dimension of torque will now be force. What's the dimension of torque? Will now be, the dimension of force is mLT raised to power minus 2 times distance. What's the dimension of distance? Distance is measured in terms of length. So the unit of length is L. So you're going to get L times L in indices. Remember I told you are going to apply principle of mass. When you have L times L, what it basically means, let me just write it out and let's express it. M times L means L1 plus 1 T minus 2. Now you're going to get ML2 T minus 2. So this becomes the dimension of torque. So you see, from basic principle of mathematics, understanding of indices and all that, and knowing just the formula for torque, we're going to get the dimension through the expansion method you know. So this is the expansion method that you basically see in most textbooks. Before we go to our shortcut method, remember, you just have to do this for those that are beginners. This is both for beginners and advanced. If you have done dimension before, no problem. There's something that's advanced for you that you shouldn't miss. But if you're a beginner, this is for you. So let's really go on to dimension of power. Now the dimension of power. Dimension of power, let's quickly run with this one. Dimension of power, what is power? Power equals to work done over time. Now, power equals to, what is work done? Work done equals to force times distance over time. Okay, now, so what's dimension of, what's the unit of force? I want to use units this time. Remember the previous time we were using, we express in dimension, express force in dimension, express distance. Now I want to show you how you can also get it from units. Now we have kilogram, they are both under the expansion method. So we have unit of force is kilogram meters per second, and the unit of distance is unit of distance is meter. Then the unit of time is seconds. Now from there we have power equals to kilogram meters per second square times m. Okay, I wanted to multiply this two. So m times m will give you m square over s. So from there, kilogram is what? M. I told that the unit of mass is kilogram, then dimension is m. So when we're talking about units, so m as a unit is meters, not mass. The reason I did this stuff because many persons confuse. So maybe when your secondary teacher taught you, they use this method, they use unit to solve for dimension. So in case you are saying you express that as unit, take note that mass as unit, m as unit, not mass, m as unit is represented as L. So that's the unit of length, meters, and it's m. So please take note. So we have m square, ml square. Then s is time. That's second. The unit of time is second. So we're going to have t. That's dimension of t of time is t. Then minus 2 over dimension of s of seconds again, time. So from there we now have ml2 t minus 2. If you bring t up again from our laws of indices, you now have t minus 1. If you want to express it in basic form, ml2 t minus 2 minus 1. You're adding two of them. to give you your final answer. If I was in the exam, I will skip this part. For me, I think that it will be ml2t raised to the power minus 3. Just for your understanding sake, how I'm doing all this. Then ml2t minus 3. So this is the dimension of power. This is the dimension of power. So please take note. This dimension of power using the expansion method. Now let's quickly run to the shortcut method so we can finish. So this video will not be too long. Let's quickly go to the shortcut method. We're going to be expressing both this dimension of torque and power using the shortcut method quickly. Now, Dr. Jeremiah's first method of solving dimension, his first shortcut, is called using force as a reference. Using force as a reference. Take for instance now, let's quickly go on. Torque, we said torque, we're in units of torque. So it is the formula for torque. Torque is force times the perpendicular distance. So force times distance. When you know this, now all you need to just know from this using force as a reference, just know the unit dimension of force. Just know the dimension of force. This is the shortcut. Just know the dimension of force. The dimension of force is mlt raised to the power minus 2. Just have it at your fingertip. mlt raised to the power minus 2. So this is what I'm going to be using for this first shortcut method. So it's called using force as a reference. Now we know that the dimension of force is ml2 minus 2. When you just in your example, after you have written your formula, just quickly bring ml2 raised to the power minus 2. No need to solve anything. Times distance. When you know the unit of distance, the dimension of distance is L. So from there you just have ml2. When you times this 2, it's going to be 1 plus 1. So it's ml2t minus 2. In less than 20 seconds, I've gotten my question in the hall. You see, that's what this method is all about. Now let's quickly just run power and see. Power is work done over time. What is work done? Force times distance over time. You see, I don't need to now start deriving the dimension of force again. I know that it's mlt raised to the power minus 2 times distance. So distance is represented as L, time represented as t. Now I cannot do my basic derivations like from indices. L times L give me ml square. T raised to the power minus 2. When I bring this one up, now becomes t raised to the power minus 2 minus 1. So it gives you minus 3. I've explained it in the previous one. So let's just watch. See, this is the way I will solve it in an example. I solved it in less than 5 seconds. That's right. I've gotten my answer. So you see, questions on dimension should be bonus. The reason for this video, you may know dimension before, but when I've taught you that you have to use force as a reference, it saves your time in the hall. So the reason for this video is to save your time. Yeah. Apart from the other things we're looking at, the complex things we'll be looking at later, this reference, using force as a reference, is just to save your time in the hall. Use 20 seconds. Don't use more than 20 seconds to solve your dimension question again. Just save time for other big stuff. Now let's quickly add to show that this thing is not. Some people be like, can this thing solve every question? I'm not using force and I'm not using torque and power. Like I told you, I want to give you a bonus using gravitational constants. Let's try it using gravitational constants. Apart from torque and power we have done, let's quickly try gravitational constants. So gravitational constants. G. Now, but before we get here, what is the formula for force in gravitational field? The force in gravitational force. The formula for gravitational force is F equals to G m r square. F equals to G m r square. You can write m square anywhere before. But why I just like writing mm is because this mass is that of the planet. There are 2 planets or 2 bodies involved. So this one is for the first body, this is for the second body, just to differentiate them. So you can write m square. If you multiply them, it will give you g m square over r square. So you get it. Now, so this is what we're going to be using to look for our dimension of gravitational constant. Why I'm giving you this one is, you know, say, Dr. Jeremiah use simple stuff. So this shortcut method works for any long quantity rather in physics, because they basically must have force. They must have force inside them. Yes, they must be made up from maybe like work done now is force times this, and pressure force times this, or force over this. So you see, they are all made from force. But for instance, like they say, find dimension of mass, it's not made from force now, it's just one thing. So most of those laws that are derived from different quantities, they usually have force inside them. That's why I'm giving you this force as a reference to save your time. Now let's see this now. This gravitational constant has force. Now let's make G solve the formula. We're looking for the dimension of gravitational constant. So from here we can cross multiply, make this over 1. So we're going to have Gm square, let's just do the m square, equals to Rf r square. Now from here, gravitational constant equals to Rf r square over m square. Now what's the dimension of force? Where the dimension of force is mlt raised to power minus 2 times what's the dimension of radius? What's radius? Radius is measured in terms of length, and so the dimension of radius is length. The dimension of the unit of radius is meters as well. So it's measured in terms of length. Now the dimension of radius is L, so we're going to have L squared. Then also, what's the dimension of mass? Dimension of mass is m. We're going to have m squared. Now, so you see, we have saved ourselves from the stress of looking for dimension of force from the beginning. Now, what are you doing next? G equals to, bring m up. We're going to have m1 raised to power minus 2. We are bringing the 2 up. We're going to have L1 plus 2, because you are times in L times L squared. Then t raised to power minus 2. From there, when you combine everything, you're going to get 1 minus 2 will give you minus 1. So you must have basic understanding of mathematics. T minus 2. So this is the dimension of the gravitational constant. So I feel this force of reference formula shortcut is actually even enough for you. You don't need to even tell me my second shortcut again. So this one is enough to solve any question. See, we have just to solve 3 questions. I'll give you an assignment now. Look for the dimension of pressure, and let's say which other one we give you now? The dimension of, for instance now, potential difference. Now the formula for pressure is force over area if you don't know, and potential difference you can get it from W equals to QV. So from there you're going to get V. Now the potential difference is presented as V. So potential difference equals to V equals to W over Q. Common sense saying that this W will give you force. You see, you can anything in physics. Most of those things, let me just conclude that anything, but most of them you will actually have force inside them. For instance, now work done has force. Force is already even stated in pressure. So you see, tell me the answer to these questions in the comment section. Let's quickly run to the principle of homogeneity and other applications of dimension, so that this video will not be too long. So this shortcut method is actually going to give you your answer every single time and save you time. So let's quickly go to the applications of dimension. We'll be looking at 2 applications in this video. So the first one, we're going to be deriving the formula of a physical quantity from a given relation. They'll give you a statement or a sentence and say, let's derive the formula of that physical quantity. Now let's quickly run it. I'll be reading the question. It's going to appear on your screen, so read along. So here I have the period T of oscillation of a simple pendulum depends on the length L and acceleration due to gravity G. Determine the exact form of the dependence. Now, this for those writing WAEC, NECO, 100 level exams, JUPEP and all that. Jamb will not ask you this if you're writing Jamb. But this just for you, for extra knowledge. So you'll do this very soon. Alright, so the first thing you have to do here now, what did they give us in the question? They said the period T, just read the question as I go. They said the period T, let's write it somewhere here. The period T, so you have time, period. Then depends on length. You have L was given. Then also we have acceleration due to gravity. So the first thing first, when you are solving questions on the applications of dimension, where you are deriving the formula of the physical quantity from the given relation, the first thing, I'm going to break it into 10 parts, please, for your understanding. The first thing is to form the relation. So the relation here now, they told you that period depends on, read the question, period depends on, so we're going to have period is t, it depends on, so equals to L length, it depends on the length L. We're going to put x on top. Look at the way I'm solving this question, ls and gy, so we're going to call it equation 1. So the first thing first is that we have to form a relation from the question. Now this simply means that period depends on length and gravity. Why do we put this s and y? Because we don't know the power yet. It can be 0, it can be 1, it can be -2. Hope you get. So the first thing is to form the relation. Now the second thing is to express this relation in terms of the fundamental quantities. Express in, let me just shorten it, fundamental quantities. Okay, let's write quantity. Okay, ty, to express in terms of fundamental quantity. Now we have t equals to ls y. Now the fundamental quantity of t is ct, of L is Lx, and of G, what's fundamental quantity? What's gravity? Gravity is acceleration. It's shortened as gravity, but acceleration is to gravity. So it's acceleration. Now acceleration is what? I think we have done in this video. Velocity over time, velocity over time. And the dimension of acceleration is L_t raised to power minus 2. We don't have to go back there, I've done it. So L_t raised to power minus 2, we're going to have Lx times Lt raised to power minus 2. Now, many students fail this in exam, or why? Because they just write y here. But it's wrong. I always tell my students that when you are expressing something that you are expressing multiple stuff, it's better you put them in brackets. Yes, to avoid mistakes. So I'm going to have Lt raised to power minus 2, open bracket and close bracket y. So you see, this becomes equation 2. We have expressed everything here now in terms of the fundamental quantities, that's L and T, length and time. So that's the second thing here, expressed in terms of the fundamental quantities. Now let's quickly go to the third thing now. The third thing is to open the bracket. I'm breaking it down into bits so that if you are a newbie, you get it easier. So open the bracket. So while we open the bracket now, we are going to have T equals to Lx times, when you open the bracket, you're going to have Ly, because this thing is both for y, for L and T. So the y is outside. Note that G, the y was on top of G. So we express G as L raised to power minus 2. So both L and T take this y. So we're going to have Ly times, this is supposed to be Ly, times T minus 2y. Yes, minus 2 times y is minus 2y. So we have reduced the bracket now. Now let's go to the next one. Number 4 now, we're going to now be that we are going to express t on left hand side in terms of okay, we only have L and T. So we're expressing L and T in terms of L and T. Why we're expressing in terms of L and T? When I'm writing in your own notes, you can write it in full. I'm just writing in writing shorthand now. So express T in terms of express T on left hand side. This is left hand side in terms of length and time. We're going to express this T. Why? Because we have L and T here, not just T. So we have to bring L also here. Now how do we do this? Now here we have T raised to power minus 1. So T raised to power 1 rather, not minus 1. Remember I told you that your understanding of mathematics is very, very important. You need to understand math to a great extent. Now, L here is not here. What does it mean? It means that L equals to Z. L is raised to power 0. Know that anything raised to power 0 is 1 in mathematics. Yes, so it means that in this place we have L raised to power 0. That's why it's only T that is showing here. L raised to power 0 is going to give you 1. So 1 times C is CT. So it means that L raised to power 0. We have to bring this L here so can express the dimension, so can form the equation. You see why it's important now. So we are going to have L raised to power 0, T raised to power 1. We're going to express all of them in terms of their power. Now we now have Lx times Ly T minus 2y. Now what's the next step quickly? What's the next step? The next step here, number 5, is that you express, or let's not say express, add same quantities on the same side. Like add same quantities. Add same quantities. Add same quantities. Now, for here now we only have L and T, so we're not adding anything. L0, T1. Then now we have 2L here. We have to bring 2 of them together and add them from indices. When you have times means what? Times means plus. So you have Lx plus y T raised to power minus 2y. You see, we have been using indices ever since. No math to an extent is very important. If you have not watched that video, please go and watch that video. I said so many things on why you must know math. So you see, this is the practical explanation of that stuff now. Now, number 6 here is, you must, now that we have expressed everything in terms of, we have brought same quantities together. Okay, now, so we want to now equate same quantities on same side. We want to equate same quantities on same side. So we're going to say, equate same quantities on both sides. Just writing like that in your notes. Equate same quantities on both sides. So now we're going to have quickly, if we equate same quantities, we're going to have L0 equals to L raised to power x plus y. So that's the same quantity on the same side. Now the other one we have now is T raised to power 1 equals to T raised to power minus 2y. So that are the 2 quantities we have on the same side. So you see, we have been able to express 2 of them on the same side. Now the next thing after this is to equate powers. That's why I say your understanding of mathematics should be very deep. Yes, there is something in mathematics that when you have same base, let's call this thing base. Yes, called base. When you have same base, you can equate the powers. It's from indices also. You can equate the powers. So we're going to have L, we cancel L. We are going to be left with 0 and x plus y. So we have x plus y equals to 0. So we can call this, we have called that one equation 1 here. We can call this one equation 2. Equation 3. X plus y equals to 0. Now if you do the same thing for t, you cancel the t. You're going to be left with minus 2y equals to 1. You can call it equation 4. Now you see, we are going to express equate the power. Now you see from here now, you can look for value of s and y, then input back into this initial relation. These are also form the formula for period here. You see, it's very easy. If you look closely at these equations, you will see that you can express y here because now there's no other unknown here. But this one, there are 2 unknowns, so you cannot look for it. But you can express y now, you can reduce y to the barest minimum. We're going to have, let's quickly do this. We're going to have y equals to 1 over 2 minus 2, which is going to be minus 1 over 2. Why do we do it like that? If we divide both sides by minus 2, we are going to get, to make y stand alone, we divide both sides by minus 2 from normal mass. We're going to now get y equals to minus 1 over 2. Now you see, we have expressed y in lowest form. Y equals to minus 1 over 2. Now we can equate this stuff into this stuff and get s. So the next point is that you equate, sorry, not equate, you substitute y equals to minus 1 over 2 into equation 3. Now if you substitute into equation 3, you're going to get s, so we have to go down, s plus y equals to 0. Now what is y? Y is minus 1 over 2. We're going to get s plus minus 1 over 2 equals to 0. Here we complete this now. Let's quickly run it here. S plus, remember, s plus minus 1 over 2 equals 0. Now plus times minus is minus. You must know these things from mathematics. So we're going to have x minus 1 over 2 equals to 0. I'm going to get x equals to 1 over 2. If you bring 1 over 2 to the other side, it becomes positive. So we have gotten the answer as x equals to 1 over 2 and y equals to minus 1 over 2. See, it's very easy. Once you get y, because y does not have any unknown standing with it, you substitute your value of y into the other equation. This is how you determine the dimension of the formula of any relation that you are giving example. You basically be giving one that you can get directly, then you substitute into the other ones. If it's 2 or 3 unknowns, you substitute. And just that in this question we only have 2 values, 2 quantities. But there's some times that maybe it will be something like t equals to lx gy, maybe m, let me just use mz. So you have 3 unknowns there. So it depends on what you are giving the question, what the quantity is dependent on. So I think with that we have gotten x and y. Now let's now substitute into our what we use now. Let's substitute to the final thing. Let's just write it. Number 9, substitute. Okay, this marker is not working again. Number 9 is going to be substitute value of x and y into, what's the first one? Equation 1. Hope you can see it. The board is full now, but just try. So to substitute this value into equation 1, we're going to now have t equals to l. What's x? X is 1 over 2. X is 1 over 2 times g. What's g? What's y here now? Y is minus 1 over 2. So you get t equals to l times l1 over 2 times g minus 1 over 2. Now this way you also use indices again. Everything here is related to indices. That's why I say you cannot throw away mass. So now when you have something 1 over 2, what does it mean? It actually means the root of that stuff. So take for instance, I have m over n. What it just means, maybe I have k raised to the power m over n. What does it mean? It just means the root, n root of k raised to the power m. Just hope you got that. So this under means root, while this one means power. So here now, this means root, square root of l raised to the power 1. So there you basically have root l raised to the power 1. So 1 is still give you the same thing. So let's forget about that. Now here you also have root also, but take note of something. This is not for me. This is when you have minus 1 over 2, always bring it back. Always change it to this form, the inverse form, so it will remove the negative sign. So if I bring 1 now, I make 1 over g 1 over 2. The minus sign will be gone. But if I'm bringing it up now, that becomes g raised to the power minus 1 over 2. Now it's enable us to be able to express it better. Now we're going to get, this one gives you 1 over square root of g. Yes, because 2 is also square root. Like I told you, that the bottom of the fraction that's given as power is root, while the top is power. Now see, we now have, well, what are we left with now? We're left with, let me erase this part. We are left with t equals to square root of l times 1 over square root of g. if you multiply both sides, you're going to get t equals to square root of L over square root of G. Now you can bring a bigger square root since both of them are square roots. You're going to now get square root of L over G. I don't know if you remember this relation in physics. So time or period rather, period depends on length and gravity with this equation, by this equation. So this is the relation that we have gotten. So this is the formula we have gotten from that relation we were given. Like I was saying, I'm not remember this formula in physics. Yes, formula in physics. You know, it's I know someone will be like, what is so you remember is t equals to, let me write it here. T equals to 2 pi L over G. Remember the formula now. This is the formula for period. But why is period not included here? The relation we're given, let's I think the question will show on your screen. Let's read it again. It says the period of oscillation of a simple pendulum depends on length and oscillation to gravity. Determine the exact form of the dependence. Now let me give you as a bonus. This is why you see in your questions in Jamb, they'll say period depends on this and that. Period does not depend on these guys. They are just constants. They are just constants in the equation. 2 pi is just a constant. Period does not depend on them. Period only depends on length and gravity. So that's just a tip for you for watching to this point. So that's why even in the question they say period depends on so and so. They didn't mention this guy, but it's in the formula, but not dependent on it. So we are gotten from this relation that we're given that period equals to the exact dependence is L square root of L over square root of G, which gives you big square root L over G. Now I think we are done with this. Now, I'll give you a take-home question. It's going to be shown on your screen right now. Take it as do it as an assignment, and as we go to the next application of dimension. We're not looking at 2 applications of dimension today. Go to the next application right now. So just do that question and tell me in the comment section what your answer is. Tell me your answer in the comment section below. So let's really move to the next application of dimension. So the next application of dimension we're looking at is to check the correctness of a physical relation. To check if a physical relation is correct. Many of you have seen this in past questions or textbooks, and maybe you didn't get the concept. So that's why this video is made for you. So to check the correctness of a relation. So how will we do this now? Take for instance, this is the relation x equals to a plus bk squared. So we ask you, is this equation correct? Is this equation dimensionally correct? You see questions like that, they'll give you several equations and say which one is not dimensionally correct or which one is dimensionally correct. So it depends on the way the examiner structured the question. Now, this principle I'm going to be using for such questions is called the principle of homogeneity. The principle of homogeneity. It just means sameness. Homogeneity means sameness. What does this principle state? Take for instance s equals to a plus bk squared. S equals to a plus bk squared. It simply tells us that s equals to a equals to bk squared. S equals to a equals to bk squared. Now, this principle states that every term, just watch me, every term, s is a term here, a is a term here, bk squared is also a term here. Every term in the relation are equal. So I said s equals to a equals to bk squared. How do you know a term? A term is separated with either plus or minus. Now you see, now here we have a plus bk squared. It means that a is a term here. Bk squared is also a term here. S is also a square. It's also a term here. We have s equals to a equals to bk squared. This is where your examiners can be tricky. So your examiner can ask you, let's just quickly form a, so we can have s equals to b. So this one is going to be wrong. These are not same. You can say x, okay, x equals to k squared is wrong. You can say x equals to a, then d, probably x equals to maybe bk s equals to bk. So basically this is not correct. Why? Because I told you that it's only terms that are equal, and here we only have x equals to a as a term. The rest are not terms here. So how do you know this now? When they are separated with positive or negative, that makes that that set of terms, they can be group of quantities or just one quantity. As long as they are separated with negative or positive sign, that makes them a term. So this is a term, this is a term, this is a term. Now let's quickly look at this relation also. Let's use the equation of motion as a case study now. Let's use the practical equation. We have s equals to ut plus or minus half at squared. Now in your exam they can ask you, the examiner can be tricky and say, what's the dimension of ut? What's the dimension of ut? Basically, from what I've just explained, this is a term, this is a term, this is a term. So the dimension of ut will be same as s, will be same as s because they are equal. That's just the principle of homogeneity, that every term in the relation and equation are equal, and this is how you test if an equation is correct. So for instance now, let's just try now ut. What's the dimension of u? What's u? U is initial velocity, and dimension of velocity, as we have said previously, is lt raised to the power minus 1. And t, what's the dimension of t? Dimension of t is time. So if you have lt, let's do lt raised to the power minus 1 times t, you get lt minus 1 plus 1. So that gives you lt raised to the power 0 equals to L. So you see, the dimension of ut is L. So it means this equation is correct. Why? Because we have N equals to L equals to L plus L. This one also give you L also. So every term in a relation must be equal. Every term. That's when the equation is dimensionally correct. That's only when the equation is dimensionally correct. So every relation you use in physics, every equation, they are basically dimensionally correct. Why? Because when you times the quantities that make up a term, they give you the quantity that they depend on. That's, for instance, now they depend on distance here or displacement. Now ut will give you displacement. The unit of displacement is meters, or you can say dimension of displacement is length. So they give you length, or they give you the unit meters. There are different ways they can structure questions on this. Now let's look at the basic rules to test homogeneity, although they build on this I've just said. Now, so we have x equals to y here. Now s equals to y, that's what it just basically means. So when you have an equation that s equals to y, it means, I told you that this is a term, this is a term. So it means s and y are same. Now for here now, when you have s equals to y plus or minus x, or z rather, or z, anyone you call it. So we have s equals to y equals to z. Yes. So s equals to y equals to z, because these three are terms. Why? Because of this plus or minus sign and this equal to sign. So this one shows that this is a term. But now when you have s equals to z times y, s equals to z times y. Now this is not a term. Please take note. I told you it's only plus and minus that gives you term. S times y is not a term. Yeah, s equals to zy. It's not s equals to z or s equals to y. S equals to zy. So you have to multiply these two to get s. So they say find the unit of, maybe you don't know the unit of x now, and they give the unit of s, of z and y, and so find the unit of x. The unit of s here will not be the unit of z times y. The unit of z times y will give you the unit of x. Why? Because z times y, that's a term in this relation, s equals to zy. Now it applies to this also. The unit of x is the unit of x is y over z. Why? Because y over z is the term and not just y or just z. Hope you understand. The reason I brought out these rules is just for more understanding. Although what I've said here, you understand that When it's separated by plus or minus, you have a term. But times and division does not give you a term. So please take note. Now let's look at the question. If you're showing on your screen, as I read it, just read it on your screen also. So the question says the distance traveled by a particle is given by the equation S equals to AT cubed plus BT squared plus CT plus D in meters. The unit of A is dash. The unit of A is dash. Now let's quickly just solve this question and see how this works, how this principle of homogeneity works. The question said look for A. Let's quickly write out the relation or the equation. S equals to AT cube. If you have your pen, you can solve along with me. Then plus BT squared plus CT plus D. They are all in meters. You get it? So the unit of A is dash. Now many of you now when you're in the exam will be like, how is this? What is this long thing? There's nothing bigger about it. Yeah, S is equals to AT cube because they are all tens. This is also a 10. This is also a 10. And this is also a 10. So it just basically means that S equals to AT cube. From there you can find A. No big deal about it. Now you know that this is let's that S is distance traveled. So if you want to make A series of formula, you're going to have A equals to S over T cube. A equals to S over T cube. And the we are leaving this in meters, in units rather. So the unit of distance is meters, and the unit of time is seconds. So you have S cube. So from there you're going to have ms raised to power minus t. So you see, no big deal about it. Option C is correct here. Option C, ms raised to power minus t. Just know that S equals to AT cube because they are both terms. If they say look for the unit of B now, S equals to BT squared, you get your answer. S equals to CT, you get your answer. S equals to D, you get your answer. So it means that everything here, all the quantities, all the terms here equals to meters. Yes, they equal to meter. Why? Because they are similar with S. So imagine your examiner tend to be thinking and say, what's the unit of D in this equation? The unit of D is meters. Because S and D are terms. And since S is in meters, D will be in meters. But you say, what's the unit of BT square now? The unit of BT square is meters. Because S and BT square are terms. But the unit of B cannot be meters. Because they are not terms. It's not a term here, rather. It's part of the term. So you understand? So let's quickly look at question 2. I'll give you question 3 as a take-home. So the question reads, just look at your screen now. It says, during a short interval of time, the speed v in meter per second of an automobile is given by v equals to AT squared plus BT cubed, where the time t is in seconds. So the units of A and B are respectively, they give you options. Now, let's write out the relation. Let's solve it here. V equals to AT squared plus BT cubed. AT squared plus BT cubed. Now, they say look for the units of A and B. Remember from the basis of homogeneity, we said that V equals to AT squared. That means these both terms are equal. So you have V equals to AT squared now. Now, what's the unit of velocity? Is meter per second. A, we don't know A. But we know that the unit of time is seconds. So we're going to have S squared. Now make A series of formula. We're going to have ms raised to power minus 1 over S squared. If you bring S squared up, we're going to have ms raised to power minus 1 minus 2. We're going to get minus 3 as your answer. So A equals to ms raised to power minus 1. Now let's quickly do for B also. We're going to get V equals to BT cubed. B makes B series of formula. We're going to have B equals to V over T cubed. What's T? What's V? V is ms raised to power minus 1. What's S? We're going to have S cubed. Now what is S? We're going to get ms minus 1. If you bring S cubed up, we're going to have minus 1 minus E. That gives you minus 4. So the unit of B is ms raised to power minus 4, and the unit of A is ms raised to power minus 3. So you see, we are able to get the units of A and B just by knowing that terms in a relation or equation are equal from the principle of homogeneity. Now let's test something. If I was telling you guys that since V equals to ms raised to the power minus 1, it means that this term also be ms raised to the power minus 1 as 8 is equal to ms raised to the power minus 1. Let's test it out. You can now test bt cubed by yourself. Let's test this first one. Now remember I said that V equals to 8t squared from the principle of homogeneity. Now V is equals to ms raised to the power minus 1. Now let's see if 8t squared is ms raised to the power minus 1 also. Now remember that A is what? A is ms cubed, ms raised to the power minus 3 times what's time? S squared. Now from here we have ms minus 3 plus 2 times is plus. So from there you get ms minus 3 plus 2, which gives you minus 1. So you see, this principle of homogeneity is basically correct, and this is used to test if an equation is correct. You just relate both terms and you are good to go. You have gotten your final answer. Now I will give you a take-home question just showing on your screen. Just go through the question and tell me your answer in the comment section below. Just tell me your answer. I'll be marking everyone's attempt. So let's know if you understand this topic already. Just tell me your answer in the comment section. Alright, so that'll be all for today. But I have a free gift for my first 2,000 subscribers. It's a free business package I've placed on a private group on Telegram. So send me the keyword YouTube to 081, my WhatsApp number 081 4622 7043, and you will get your package for free. Just send the keyword to my WhatsApp number and you get your free gift instantly. Now that's all for today, guys. If you found this video helpful, kindly give it a thumbs up so it can reach more persons. Subscribe to this channel by using the subscribe button below, and don't forget to turn on the notification bell so you get notified immediately I drop the next video. I know you must have learned something new today. Just let me know in the comment section what you learned from this video and what you are going to be applying in your exams. Just let me know in the comment section and I'll be there to interact with you also. So stay jiggy, guys, and don't forget to keep reading till you become the book. I remain the one and only Dr. Jeremiah, and I will see you in the next video. For now, bye.